You are listening to Season 4 of the Bitcoin Takeover podcast, a 10-part series in which hardware wallet makers and breakers get interviewed. Before I introduce this episode's guests, let's hear a few words from the show's sponsors. LXMI is a European cryptocurrency exchange whose name is inspired by Lakshmi, the Hindu goddess of wealth, good fortune, and prosperity. It's one of the regulated and legal cryptocurrency exchanges. On LXMI, you can buy bitcoins with most fiat currencies, and you can also do trading with top altcoins. They follow the not your keys, not your bitcoins philosophy with their integrated non-custodial wallet, which helps you manage your own private keys. So if you're into trading, then you don't have to worry about having your crypto frozen by whatever political decisions, since you're empowered to hold and move your coins whenever you wish. It's great to have new players like LXMI that respect your financial sovereignty. LXMI is launching in 2020, and for more information, please check out LXMI.io. If you're not into trading, it's recommended to move your coins to a hardware wallet or some other form of cold storage, and in this episode, you're about to find out why. Please keep in mind that this is just an ad for a sponsor of this show. It's not meant to serve as financial advice, and you're responsible to do your own research before buying anything and act according to your own decisions. Embrace your financial sovereignty with agency and precaution.
Phemex, 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 P-H-E-M-E-X, Phemex, P-H-E-M-E-X, Phemex.
Phemex is a Bitcoin exchange with derivative trading options, which focuses on speed, robustness, and maximum uptime. Built by former Morgan Stanley executives, it manages to bring simple and accessible Bitcoin trading. In 2020, Phemex will also add S&P 500 stocks, stock indexes, Forex, commodities, and more. Sign up today at phemex.com/bonus and receive a bonus of up to $72. Please keep in mind that this is just an ad for a sponsor of this show. It's not meant to serve as financial advice, and you're responsible to do your own research before buying anything and act according to your own decisions. Embrace your financial sovereignty with agency and precaution. Hello, and welcome to Season 4, Episode 4 of the Bitcoin Takeover podcast. I am Vlad, and I'm honored today to have as a guest one of the makers of the Ledger hardware wallet. On Twitter, his name is BTChip, but his real name is Nicolas Bacca. And he is one of the innovators in the space, and it's always a privilege to get the insights from a person who actually builds hardware wallets and has innovative ideas. And I think your position right now is head of innovation at Ledger. Is that right?
Yeah, that's correct. So thanks, Vlad, for hosting me, and thanks for the service that you are providing to the community, because the hardware wallet review was quite nice. And now, having each of the company able to speak on a podcast, speak freely and give more details about the hardware, it's I think it's providing a very useful service to the community. So yes, I'm head of innovation at Ledger. So maybe I can speak a little bit more about what I did. So I co-founded Ledger in 2015 because the company was created then. Let's say that I have been playing with smart cards for a very long time. So I have been playing with that technology for about 20 years, I think. I was there when, we created the first NFC card, so that's a very long time ago. At some point, I got bored of playing with passports, credit cards, SIM cards, and stuff. And, I thought that what drove me into creating several companies and into creating Ledger is that I think that the smart card is a great piece of technology because it's really designed to protect your secrets. But in the end, well, it's not your secret, so that's part of the problem. Smart cards are very great at holding your bank secrets, your phone provider secrets, but it's never your secret, and that's something I wanted to change. So I wanted to find a way to open the technology and to make it available for people who would like to write their own applications and in the end to hold their own stuff. So that's really what drove me into creating ledgers. So that, and of course, getting interested in Bitcoin. So when I had Bitcoin, I had this technology in hand, and I thought that it was a perfect mix. And definitely, if we wanted Bitcoin to take over, so I think that's the topic of the podcast, we needed to have a way to host keys properly and safely. And well, that's really the reason why we started everything. And since the company grew a lot, so well, even faster than I believed, so we took a very wide ride in 2017, I guess, like all the other companies. Then it was a little bit more quiet after that, but still, I mean, the space is quite exciting, and it's always great to see. I mean, every day there is something new, and it's a great space to be in.
Oh yes, and I must confess that the first hardware wallet that I owned was the Ledger Nano S. And one of the reasons why I still like it is that it looks exactly, and I mean identical, to one of my USB flash drives. If you would see them one next to the other and I scratched the logo of Ledger, you would only be able to tell them apart if you open it and see that it has buttons and it doesn't have a mail connector and it has that screen. But otherwise, you can just bypass airport security or some kind of, search just by carrying that, as opposed to the Trezor. Sometimes it looks like the remote which opens your car, right? And unless you own a car and people know that you own a car, it doesn't really make sense to carry that around. And with the KeepKey, that's even more complicated because it's bulky. And with the Coldcard, for example, it sort of looks like a calculator, but it has a very small screen. And that's the first detail that gives away that it's a strange kind of calculator. And it also doesn't have buttons for operations. So from this perspective of OPSEC, I think you nailed the design.
Yeah, thank you. And regarding OPSEC, I would like to say that you can even push it a little bit further if you want, because I will be talking about our operating system, our approach to security, and the way we split the operating system and applications in the hardware, because we are the only vendor to have a multi-application operating system, so on which you can decide which application you load and which application you remove. But let's say that if you want to push your OPSEC a bit further, for example, when you are working through customs, you can just have your FIDO application loaded in, so your second factor application loaded on your ledger, and then you can perfectly discuss that and say, okay, yeah, well, look at that. I mean, that is a completely legitimate use case. And people would have to take the hardware wallet and to install additional applications to know that you are actually holding Bitcoins. So that's something, I mean, that's a way to make your OPSEC even a little bit better if you want. And of course, I mean, for the other hardware wallets, you can also play with your passphrase, and you can always keep a small amount, I mean, in a different passphrase. I think it's a good practice to have if you want to make your OPSEC a little bit better. So of course, will tell a way that we are interested in crypto. You can't hide the fact that you have a Bitcoin application on the device, because on other devices you have the firmware and the applications are mixed in some way. But still, well, you have additional options. So I think it's interesting to see in that space that pretty much everybody thought about OPSEC, because it's important. It's important if you want to conceal your privacy and if you want to conceal your assets.
Also, before I move on to the first question, I gotta say that the previous podcast, which I recorded, and chronologically is going to be the one after this one, so episode 5, with Brian Alds of Bill Fuddle, he had lots of kind words to say about the ledger and even said that he uses one on a daily basis. So there's the praise.
Hey, thank you, and thanks to everybody, I mean, who likes the device, and thanks to everybody who criticized the device. I mean, because user feedback is what really drives us. and drives me to innovate. One of the big complaints I had about my previous job is that when I was designing SIM cards, passports, and the stuff, is that in the end you never talk to your end users, so you don't really know what to improve. And I would say that we made much more improvement in the field of smart cards in general in 5 years. I mean, now that Ledger has been created, thanks to all the user feedback and critics that we got, than what I did in the past 15 years. So the field is also great for that. And consumer electronics, secure consumer electronics is kind of a new field of business. I mean, that's how I would generalize hardware wallets, but it's a great place to be.
Oh, yeah. And speaking of, I wrote that 3-part series in Bitcoin Magazine about hardware wallets, and I really appreciated the way you reacted as a company to what I wrote there. I mean, you could slam me on social media and say that I'm wrong and possibly point out alternatives to the solutions that I found, but you just improved and sent me an email. And we're like, okay, so we have added to this Donjon. I think that's how you pronounce it.
It's Donjon, but yeah, I know it's pretty hard to pronounce if you are not a French guy. So yeah.
Yeah, you added all the list of hacks that have been fixed, and you have updated your bounty program. And these 2 points have been raised during the article. And in less than 1 month, you have fixed it. And you didn't even tell me in advance. You just told me, okay, we have fixed these. And that's something I appreciate.
Yeah, we were in the process. Yeah, we were in the process of doing it, but of course, speaking about it, just pushed us a little bit to move further into that. But that's the way you improve. I mean, you don't improve by spamming people on social media. I mean, you improve by listening to feedback. I mean, sometimes the feedback is really bad. Then okay, you can just stop listening. But insulting people never really serves any purpose, I think. Well, even if sometimes on Twitter you wonder if what people are doing, but that's another topic.
Okay, so before anyone suspects that this is some sort of paid interview in which I just randomly praise Ledger all the time, let me get to the first question, which is about hardware wallets in general, and why should anyone use them as opposed to something else like a paper wallet, a brain wallet. I spoke to Trace Mayer, and he said that he never uses hardware wallets and just stores his keys with Armory on a computer which never gets connected to the internet. And he spreads it geographically across multiple regions. But why should anyone buy a hardware wallet and use it?
No, sure. Thanks for this question, because for sure it's something that a lot of people wonder when they decide to spend a little bit more money to hold your money. I mean, that's something that you want to do usually. I think that for people who perfectly know what they're doing, who have a very strong upsec, and who are absolutely confident in their process, I mean, they can of course have something that they keep offline and that they manage their way. The idea is that if you have a hardware wallet, in my opinion, it's the best way to create a secure setup. So to both hodl your crypto, so that's one of the main use cases, and use it. And I would say that using it is really the complex part. I mean, because if you want to use a paper wallet correctly, or if you want to use crypto that you hold on an offline computer, you have to think about all the steps where things can go wrong, and you have a lot of them. So especially if you are using a paper wallet, any kind of malware can of course steal your crypto when you are using it, because you are putting your keys into memory, and you have plenty of ways to extract things from memory of a computer. If you have been following the recent hacks on Intel architecture, for example, you know that there are multiple ways of spying on what the CPU is doing. So you had things. I mean, I think the most recent one is zombie load, but previous. I mean, apart from that, you have Spectre before, and you had all those series of very interesting hacks. So when people manage to extract data from memory. But that's maybe the most complex one. But then if you have an offline computer, you have to think about how you are going to update it, because it doesn't mean that it's secure because it's offline. Well, if you have something if you have an updated software on your computer, you might still need to update it in order to avoid leaking data, or in order to avoid, for example, feeding it something that would cause a different outcome when you decide to sign. So you have a lot of things to check, and you have a lot of boxes to verify if you want to do your own self-custody. And I would say that hardware wallets make that much easier. And that's really the point in having one, in my opinion. If you decide to hold your crypto, so first, it provides you with a good entropy. So you know that you are going to choose your keys properly and that you don't wake up one morning and with all your funds disappearing because, well, the first entropy that you picked was bad. So which is something that can happen if you are using a software wallet, or if you are using something in an environment that you didn't really control. And then when you use your crypto, you can verify what you're signing. And verifying what you're signing, I would say, is really the key point of hardware wallets. So you can make sure that what you are doing is really what you wanted to do. And this is getting a bit more complex, so we'll have an opportunity to discuss that in multi-signature settings. But I think that the key, really the important part of hardware wallets is to put you a little bit more in control with an interface which is quite easy to use. So if you want to pick something, if you want to get into crypto, hardware wallets are the best way to make sure that first your crypto won't disappear and that you will be ready to use to make really a full use of the most creative use case of crypto that can be coming, because hardware wallets are ready for holding, and they are ready for using, and even in new ways that do not exist yet.
Right. So why should a newbie who just got into Bitcoin and decided to spend $100 on hardware wallet choose a ledger? And when going for a ledger, which model is best suited for the needs of a beginner?
Well, all hardware wallets, are interesting. I would say that we offer the best mix of openness, flexibility, and security. Especially if you consider a threat model which involves physical attacks. So we are pretty much, I would say, the one dealing the most with physical attacks by choosing a smart card chip. So in order to implement our logic. I can speak a little bit more about the different things I mentioned. So the openness here, we have probably the largest numbers of third-party developers today. So we have people, of course, designing support for different coins. So I'm not going to mention different coins on this podcast, but let's say that if you want to design Bitcoin extensions as well, for example, if you want to design your own Bitcoin application to exactly cater to your use case, that's something you can do. So we can have some people playing with that in the future. Regarding the flexibility, so we have an operating system today which allows you to isolate applications. So you can basically load any kind of application on your device, and you know that applications are not going to interact with each other. So each application is really independent. And regarding security, so the threat model that we have in mind is that we are building everything on the shoulders of technology that has been the gold standard for, I would say, 40 years in banking, pay TV, identity, and other industries which are absolutely critical. So by doing that, we know that we offer the best possible physical security. Not because we designed it from scratch, but because we rely on something that a lot of other people have been using in the past. So for really know how you are going to use your crypto. So are you going to hodl your crypto? Are you going to use them? Are you going to walk all the time with your hardware wallet in your pocket, for example, which can be a very viable use case? You know that by choosing Ledger, you have a solution that protects you against those kind of possible physical threats, that is still easy to use, and that is still very, very flexible. So regarding future use cases that you might have. Regarding the different models that you want to pick, I would say it's really personal taste. So the Nano S is our oldest hardware wallet with a screen. So before that, we had a model without a screen, and we had a model with an FC, but I won't really speak about that. So the Nano S, I would say, is the cheapest. Security-wise, it's pretty much equivalent to the Nano X. You might want to get a Nano S if you are using, if you don't mind, connecting it through a USB cable on your phone, for example. So if you don't mind having kind of a weird setup where you connect a USB OTG cable when using it on a phone, it's okay. The Nano X offers a bigger screen, so it can be quite useful for users who might have trouble reading on the smaller screen of the Nano S. It offers a Bluetooth connection, so which is great to connect it to your phone, so either Android or iOS as something, in a more natural way, I would say, than when dealing with an USB OTG cable. And it's slightly more expensive. So today, and it has more memory as well. So I would say depending on your use case, the S and the X are good options. If you are going to trade often on your phone, the X is probably the preferred option. So otherwise, the S is great as well.
I think the discussion in regards to the difference sometimes ends up being the difference in the secure element, because I think the X has an updated chip.
Yes. So the X has an updated chip, so it uses an ST33, while the S is using an ST31. Both are quite equivalent security-wise. I mean, the ST33 is probably a little bit more recent, so it's even more hardened than the ST31 against physical attacks, but the ST31 has been undefeated so far. So security-wise, one thing that changes really between the S and the X is that on the X, the screen and buttons are directly connected to the secure elements. So that's one attack surface that has been removed. I mean, you don't have an MCU connecting in the middle the screen and buttons. But I would say that even on the S, and regarding I can maybe talk a little bit, so quite quickly about the security architecture that we have on the S. So on the S, the secure element is executing the applications, and when the secure element wants to display something or to get inputs from the user, it's talking to an MCU, so which is a non-secure chip, which is connected to the screen and button and reporting the events to the S. So you would think that it's an easy way to attack, because if you can run code on the S, so which some people did in the past, you have a way to basically fake what's displayed on the screen, and you have a way to fake user inputs. But when the device boots, the secure element authenticates the MCU. So by basically, the MCU is going to send its firmware to the secure element, and the secure element is going to hash the firmware and to verify that it's talking to the right chip. So, there are ways to try to hack that, but I would say it's not really easy to do with the new security that you put in place. Basically, the secure element is verifying that the timing is correct. I mean, that the MCU is answering at the right time. The firmware is asked to the MCU in a random way, so it's hard to reproduce. So today, with the new strategy that we put in place in the recent firmwares, I think it was right after 1.3.1, I haven't seen a hack that would exploit that successfully. So I have seen people running code on the MCU, but I haven't seen people running code on the MCU while still talking to the secure element. So security-wise, I would say both are pretty much pretty good today.
Right. So I think that the next question that I have for you is the most difficult of this entire interview, because I will make you discuss the competition, and I'll make you say something nice and something bad about them. And let's begin with the Trezor, because this seems to be the never-ending battle between hardware wallets.
Yeah. Well, it's not really a battle. I mean, I really like a lot what Trezor is building. I mean, the ethics, regarding doing everything open source, making sure that you can build your own, pushing people even to build your own, providing clear instructions on how you can do that is quite exciting for hobbyists, I think. I also like the contribution that they make to different standards. I think they move the space a lot regarding that. Typically with Slip 39, for example, so Shamir's secret sharing of seeds, it's a great way to provide an additional backup strategy. We plan to use it as well in the future, so that because interoperability is important as well. And I think the code quality of Trezor is quite impressive as well. I mean, today we have been doing several physical attacks on Trezor because when the code is great, it's easy to attack the hardware. I mean, it's easier to attack the hardware, especially in that case. I would say that what they did build, from scratch is pretty impressive.
So your criticism regarding the Trezor is that it's easy to physically attack?
It's so what I do not like, I would say, is that yes, today the security architecture makes it really easy to physically attack. Yeah, and there is not really, there are no really ways you can prevent that. You can of course prevent that by having a passphrase. That's the typical answer. Problem is, if you have a passphrase, in my opinion, you are completely changing the model. The ease of use of the device. If you have to type something before you start using it, you are building something completely different. It's like a bit if you are telling to people that you are going to get rid of passwords by using a device that needs a stronger password. That's in my opinion. If credit cards have been successful in the past, it's also because you can just pay by tapping a credit card if it's contactless on a payment terminal, and you would pay in under 200 milliseconds, I think. So yeah, that's what we are competing against. As an industry, we are competing against the best possible use cases of the other industries. We are not competing with each other. We are competing with what happens with the existing banking system, for example, with the existing scenarios. So we have to be better than that. And if you have to enter a passphrase before you can even think about using your device, I think you destroy a lot of ease of use and a lot of user experience.
What about the KeepKey? It has been around for a few years. Nowadays, I think is the most affordable hardware wallet out there, and might be a good solution if you just want to connect to Electrum and not use the Shapeshift software. What do you think about it? Can you say something nice and something bad about it?
So something nice, I like the large screen. I think the large screen changes the user experience, and you can have, of course, a lot more information. That's what they did in the beginning. Something else I liked is that they probably showed to other people how you could make a tighter integration with an exchange. Because what they did with Shapeshift is that you could verify your shift on device. So that was getting one step further, from just displaying simple information. You could display information that related to the service that you are interacting with. And I think that it shows how hardware wallets could, in the end, provide a better integration into third-party services. So you could have, a better interaction, and you could even, for example, when interacting with an exchange, you could verify what you are currently doing on the exchange. You could verify the different trades that you are doing directly on device, and that would be great. So I think they showed that hardware wallet could be used to do that as well. So that's on the parts I like. On the parts I don't like, I will probably say the same thing as Trezor, because they are using the same architecture. So security-wise, I don't think it's security-wise, I think there are problems that you can't really overcome with software. So that's my bigger concern.
Right. So what about the newest big player in the market, the Coldcard? It brings a lot of interesting features. It even uses partially signed Bitcoin transactions, which is interesting.
Yes.
That you never connect the device to the internet. But to somebody who is new in the space, it can be very intimidating and difficult to use and unfriendly. I think I criticized it. I feel like I did your job, but can you say something nice about it and something you don't like?
No, sure. So I think Coldcard is basically catering to the cypherpunks. You can see that with their communication on social media to use them. If you are thinking about using your device for anything else than Bitcoin, basically they don't want to be talking to you. Which is it's a marketing position. That's fine. If they make money that way, I'm very happy for them. So that's fine. What I like with Coldcard is, as you said, support of PSBT, because it was definitely built for PSBT, and having a hardware wallet pushing PSBT is something great for how it can be integrated. And I think pretty much all of us will be integrating PSBT at some level. So today you can already use PSBT with an external integration, so using the HWY interface. So everybody can interact with PSBT, but Coldcard show how you can deeply design your hardware into exactly supporting PSBT and displaying different PSBT elements. And I think I kind of like the looks, of the Coldcard as well, because if you are targeting cypherpunks, it's good to have a device that looks like something very intimidating. So it definitely looks intimidating, and I think it's a nice feature.
What about the BitBox 02, which was launched a few months ago? And I think it uses the same secure element as the Coldcard, but is a lot friendlier. And from the user interface, as far as I could see when I tested it, it offered the user the option to connect to a full node and also manage UTXOs, which is impressive. And it has batch 32 addresses by default. I mean, I feel they got a lot of stuff right and they improved on the previous design, but we have yet to see how secure it really is on the long term.
Yes, so I definitely like the form factor of the new BitBox. I think what they did with the touch sliders is interesting because it's put on different. Well, you have some sliders up, you have some sliders down, so you can think about doing some different interactions. For example, when you try to enter your mnemonic inside the device, it really makes it easier. I mean, by the way, they decided to design it. Well, what else? I mean, and yeah, the set of features of the support is quite great. What I didn't like, about BitBox is, well, I would say the security. I will speak a little bit more later about the security architecture, but of course, yeah, sorry about always saying that what I don't like in competition is the security architecture, but that's a bit our that's kind of the thing that we are pushing for. And regarding Coldcard, yeah, just remembering, I didn't say what I didn't like about Coldcard before. So I would say I like the looks and I dislike the looks as well because, well, if you are a new user, I don't think it looks very friendly to you. So I understand, that even if it's not the main part. And technically speaking, one thing I don't really like about Coldcard is the usage of MicroPython as well, because I noticed that it's a new trend in this industry where a lot of people start using MicroPython. I think that it adds a lot of complexity. To review the code, you don't exactly know, what the VM is doing in the background. And as a VM it doesn't really serve the right purpose of a VM, in my opinion, a virtual machine, which is to isolate your applications. You can't really isolate applications in Python. So MicroPython makes applications easier to write, I would say. But in the end, it makes them also quite harder to understand exactly how the application is running inside, and that's not a good thing for security, in my opinion.
Interesting. I think this is the first time when I hear anything related to. I think you're referring to the operating system of the device.
Yeah. Even if they don't really have an operating system, because what I would call an operating system, it's something where you have a clean split between the main device functionalities and the application. In all of those devices, it's kind of mixed together. So the firmware is kind of doing everything, and you can't put a clear split where the device functionality starts and where the application starts. So it's kind of all mixed together. And MicroPython, using a virtual machine can be a way to do that. But typically MicroPython doesn't let you do that just because the way Python is defined. You can't have separated scopes in Python. So if, for example, you have a malicious application that tries to modify the way your device is going to handle the pin, let's say, it will be able to do that just because MicroPython and Python will not offer any kind of software protection against that.
This is definitely interesting, and this is why I'm happy that I get to talk to an engineer as opposed to a marketing person.
Well, yeah, you can find a marketing person interested in MicroPython as well, but yeah.
Okay, so you spoke about the firmware. And this is the point where I have to ask that question, which gets asked all the time. Which part of the Ledger software gets open sourced and which part doesn't? And why do people usually criticize it for making you trust the company and the device a lot more than the Trezor, for example?
Yeah, so I would say that today the approach that we have chosen when decided to work on a smart card chip is that, well, we took the good parts of it. The good parts of it is the security, and we took the bad parts of it. And the bad part of it is that you have to sign a vendor NDA, where basically the chip datasheet is under the NDA. So in what you are writing, in the code that you are sharing, you can't share anything that would either reveal how the chip is working, or you don't want to share code that will help people get this information. So it's a bit tricky because you don't want to show this information yourself, and you don't want to provide third parties with a way to extract this information. So you have to think about that when you are designing an application for a secure element. So today, what we did and that's one of the reasons why we have this operating system architecture where we split the OS from the applications, is that the OS today is closed source and the applications are open source, because the applications are using the operating system as a service. So they are basically running. At some point, they need to run a specific operation. So they are making a system call. The system call will go back to the operating system. The operating system will do its stuff and will return the result to the applications. And, well, unfortunately today, the cryptographic library is part of the operating system because for performance reasons. In the end, the secure element is working at a pretty low speed, compared to a general microcontroller. So secure element will be working at, I would say, something like 20 to 40 megahertz, while the Trezor is and other general microcontrollers are more operating in the 100 megahertz range. And so, in order to perform fast computations when doing, for example, an ECDSA signatures, they will use a coprocessor. And here you see the problem is that since the chip datasheet is under NDA, the design of the cryptographic accelerator on the secure elements is also under NDA. So that's a big part of what you can't reveal. And the way we plan to work around that is that we are rewriting constantly the operating system in order to split better the parts. So it's very hard to do it in one go. That's why it's taking us a lot of time to do that. But we want to end in an architecture where we can share most of the code of the operating system, and we will just have a black box, which will be a binary blob that you load, which will basically map the chip datasheet. But everything else will be open source in the. I don't like to say in the long run, because that's something that we are really trying to improve, but it's very hard to know exactly when we will be able to release that. So I'm pretty confident we will be able to do more, to release more things related to the crypto library this year, because we have found some ways to split it already. But yeah, well. So today the operating system is closed, so that's the way things are, and the applications are open. So you can say that, well, that's a design that makes it hard to test things. But in the end, testing the applications is pretty, and even testing the operating system is pretty possible. We had researchers reporting bugs on the operating system already, because if you want to test, you can still test it as a black box. So you can basically run some code. You can try to interact with the operating system as an application would do. You can try to override the securities of the operating system, and basically you can verify that, well, either you can't override them, and that's good, from a security point of view, or you can override them, you can make a nice bug report to us, and then we're going to fix it. But, well, we are in a state with the last certification that we passed where the code has been reviewed, by two or three, three different third parties right now. So the code which is not open, of the operating system, and yeah, I haven't found any escalation process where applications could compromise the operating system in the recent versions of the firmware. So, well, and even considering what people are doing in other industries, a lot of people are testing things like that. Using black box testing, because if you consider hardware in general, hardware can always be seen as a black box at some point. Even if your code is fully open source, your code will rely on the chip and sometimes on part of the chip which are not documented. So taking into example, all the other hardware wallets working on open source, having an open source code but working on general purpose chips, they are using security features of those chips for their own protection. Because one of the key features of a hardware wallet is that you can't flash your own code. So you can maybe do it after getting the authorization of the bootloader, or after getting the authorization of some other parts. But in the end, I mean, you don't have access to the G tag. You can't flash directly your code into the microcontroller. So you are still relying on the microcontroller for security, and unfortunately those parts are usually not documented because, well, even on general purpose microcontrollers, some parts are still kept secret by the manufacturer. So they give you the datasheet, but they are not going to tell you exactly how the datasheet is implemented. And that's when things start to get tricky, because if you think that you are protected by just writing open source code, first, you don't exactly know how that code is going to run on your specific device. So that's, I mean, if we want to think about, for example, timing attacks, today, if you want to evaluate a cryptographic algorithm running on a specific chip, it's much easier to actually run it, to take some measurements, to see how the code is behaving on the chip, rather than by reading the source code. I mean, if you just read the source code instead of running the code and observing how it's running on the hardware, you are going to miss a lot of good things, and you are going to miss a lot of hints regarding the security of the code. So that's the reason why I think that, well, even if you are fully open source, you still need to have the black box approach to testing.
Okay, I feel like this explanation was a lot more than I expected, and I'm happy that I got it.
Yeah, no problem.
Okay, so to my knowledge, I think the Ledger was the first hardware wallet to implement the secure element chip in its design. Mm-hmm. And since then, companies like Coldcard and BitBox have also added secure elements in their hardware wallets. So what do you think about this trend to add secure elements? Is it the best approach? And what do you think about the specific choice of secure elements in the Coldcard and in the BitBox?
Mm-hmm. So I think it's a good idea to have chips which are more dedicated to physical protection of assets. I mean, in all cases, because, well, as we've seen, I mean, if you try to put secrets on an STM32 on a general purpose, I would say microcontroller, they are quite easy to extract. But the problem is that in the industry, we don't really have a standard to say what's a secure element and what exactly is a secure element. So in the end, secure element gets more into, well, a marketing term, so that you are speaking about marketing people than anything else. So I would like maybe to specify, to speak a little bit more about the definition that we are using when we say secure element, and that's why I will stop saying secure element, I think, as of today. I will say that we are using a smart card chip because the definition of the smart card in the smart card industry, what we call a secure element, is a smart card chip that could come in different form factors. So, well, the most common form factor of the smart card chip is what you have on your credit card. So you can look at it, you can see the different contacts, and, well, it looks like a smart card, but you can put it into a different package. I mean, you can put it as something that you solder into something else. You can virtualize it into a CPU, for example, if you want. But in the end, it's a smart card chip. And what is exactly a smart card chip? So I'm going to dive a little bit more into what it brings and what is interesting for us. So first, it's something that is going to be quite hardened against physical attacks. So that's one characteristic that will be shared by many chips. It will give you a root of trust down to the manufacturer. So I think that's something as well extremely important. And it will give you the possibility to run code in your chip. So why do we think that all those parts are important? So first, hardening against physical attacks is quite easy to understand. I mean, it makes it hard to extract secrets. It makes it hard to spy on the chip. And as well, it makes it hard to tamper. Because let's say you want to tamper a chip. You had some very interesting talks about that at the latest Chaos Congress, so regarding chip, how you could compromise a chip. So one of the talk was from Bunny, called, I don't exactly remember the name of the talk, but it was like open source is not enough if you want to properly protect your hardware. So I would say that everybody should watch this talk if you are interested in that topic. And Bonnie has done a lot of good stuff for open hardware. So, I was digressing a bit. So the second part of what the smart card chip is going to bring is a root of trust. So the root of trust will be a manufacturer secret that is built in and that clearly identifies the origin of the chip. So since the chip is good at keeping secret, you know that this root of trust will prove that your chip is coming from a legitimate vendor. And well, that's something that has been used in critical industries that I mentioned before. So the life cycle of the chip is clearly controlled and audited, and that's a very big difference compared to a general purpose chip, because here you know that you have a secret that you can trace back to the origin. And you know that the OPSEC of the manufacturer is quite strong as well, because if this secret is leaking, basically their entire reputation goes down the drain. And I mean, not only for crypto, but for passports, for states, for other things. So, that's a good thing in using chips that are used by governments is that in the end, I mean, you know what kind of security they want to do because they want to protect themselves. So they're not going to hack themselves. I mean, if you see the point. And then it's possible to run code in the chip. And I think that's also critically important, because if you combine that with a root of trust, it means that you can give strong guarantees to an observer that what is running exactly in the chip. I mean, if you don't have that, it's pretty hard to say, okay, this is the code that I built, this is the code that I put in the chip, and this thing could temper the code in the middle. I was talking about the bootloader architecture, for example, on a generic microcontroller. Your code, when you load your code on a generic microcontroller, you are going through a bootloader. Regarding hardware wallet, you are going through a bootloader which is designed by the manufacturer of the hardware wallet. So if this bootloader is lying to you, in the end, even if you build the code yourself, you don't really know what's going to be loaded on the hardware wallet. And unfortunately, since the chip is not made to protect you against that, you have an issue. So coming back to smart card chips, if you have all those properties, so if you are hardened against physical attacks, if you have a root of trust, and if you can run code in the chip, you can provide very high guarantees regarding what you are doing, and you can use these features to save time, I would say, as well when implementing some security measures. Because what we do, I mean, when you load a new firmware into your Ledger device, you are connecting back to Ledger servers. Ledger servers will verify that the secret that's inside your chip is actually, something that your chip is legitimate. So that's how we verify that, you are talking to a legitimate Ledger device. And you have a health check that you can perform at different stages of the life of the device. And it's a good way to increase the security. And I will say that a little bit down the road. I mean, we want to explore new ways to work with multi-signatures, and especially threshold signatures and MPC, and I mean that kind of key, different ways to split keys that we can imagine. And being able to verify the code that you are running into the chip and running in a trusted environment is a way to save time, because those operations are usually very, very costly performance-wise. And if you can make some assumptions about trusting the code that is run by different parties, you end up just having code which can actually run in a time which is interesting for the user. So going back now to what Coldcard and BitBox are using, so they are using an AT-ACC, which is sold by the manufacturer as a secure element. I think that the part which is a bit confusing is that the AT-ACC will just provide the hardening against physical attacks. I mean, you don't really have a root of trust you can at least use for your own code, because you can't run code into the chip. So in the end, you have all your business logic running in a non-secure element that you can't really tie to the chip, because if your code is not running in the chip, you can't really demonstrate anything about your code, because then the relationship between both is quite weak. So another thing that is quite weird about the AT-ACC is that it's protecting keys, but you don't really know how, because it has never been certified. So I'm not saying that certification is a silver bullet, providing you confidence about what happens, but certification is giving you a list of what the manufacturer tried to do when protecting the device. So for example, you know that the manufacturer tried to protect against different kind of glitching, because when you can read the certification, all certifications are public, so certification will refer to a list of things that are actually certified. If we are talking about common criteria certifications, you have a protection profile, which is linked to the certification. So this is the information that the certification is giving you. So the certification is not telling you that the chip is good. Certification is telling you, okay, the manufacturer tested against those attacks. And for the ATECC, since it didn't really go into a certification, well, you know that the chip is hardened, but you don't really know how. So that's the reason why I don't think those chips have had a proven history in other industries before. And, well, their exact security is yet to be demonstrated.
I think I lost you for like 30 seconds there, but I hope that the recording is fine in the end.
Yep.
Anyway, this thought just came to me because I know that Ledger takes security very seriously, and at some point, I suppose there will be inevitably some sort of second-hand market for hardware wallets and users resetting their devices and selling them on eBay or something. But at this point, do you think it's safe to buy a Ledger on eBay and securely use it if it has been reset?
If it's an S, you might want to verify that people didn't put you some extra hardware inside. So I don't think that's going to be the most common attack. But sorry, are you still hearing me? Just checking.
I hear you well.
Oh, okay, sorry, because I didn't. So I think if you verify the chip is exactly, how the device is wired. So if you do that on eBay, I would probably say that, well, you should do that. if you order it and you think the device looks to have been tampered with, you might want to verify that everything is correct before storing money on it.
Okay. Because I spoke to the Shift Crypto BitBox people, and they were like, no, that's a terrible idea, and we don't think that's the way to go. And it's interesting.
I don't think that's the way to go. Yeah, I don't think that's the way to go either, but you can't really prevent people from doing it. So in the end, you want to provide some advices, because you will still have people wanting to do that. So yeah,
I suppose there are also people who get a Trezor or a Ledger at first, and they learn how to use the hardware wallet, and then maybe that they have higher privacy expectations and switch to the Coldcard, and they're going to have like a Ledger lying around. And the question is, can they still sell it and make some money on it and possibly securely give it to somebody who can trust that it's not going to be a malevolent piece of hardware? Or should they just keep it because hardware wallets are single-use items, just like toothbrushes?
So yeah, that's a good comparison. So I don't think they're single use, but I think that you can always find new use cases for a hardware wallet. Typically, if you are moving to a Coldcard because at some point you decided you are a hardcore Bitcoiner and you don't want anything else than Bitcoin to touch your device, that's a decision you have the right to take. I would say regarding privacy, it's more related to the software that you are using to connect to the hardware wallet. So the hardware wallet doesn't really play the hardware wallet doesn't do a lot of things regarding privacy, so it's more the software that you connect to it. But you have a lot of uses for a hardware wallet. If you decide to keep it, typically using FIDO, you can use your hardware wallet as a password manager. You can use your hardware wallet to connect to your SSH server. So you have plenty of reasons to keep your hardware wallet, I would say. If you decide to sell it, we are probably the manufacturers that took the most. We took care, by having the architecture that we have, of making sure that it's hard to tamper with the device. So I'm not saying that it's impossible to tamper with the device, because if you want to solder new stuff into your, we have no protection against that. But it's significantly harder than to tamper any other device, because if I want to take, just taking an example, if I want to tamper another device just based on a general microcontroller, even if you are using a secret chip, another secret chip in the middle, I just need to tamper with the bootloader. If I can somehow rewrite the bootloader and reship the device with a different bootloader, I can make you believe that the device is completely genuine. You wouldn't be able to do boot of trust. And then you can make fake devices that look exactly like the original one, without even opening the device. So for other manufacturers, I would say the second hand issue is more harder to tackle than with us, because to mess with the device, you really need to open it, and you really need to solder new things inside the device.
Another question that I have for you, and I'm not sure if it's fitting given how the operating system and the applications are handled on the Ledger, which is very different from other hardware wallets. I have seen that with the Trezor and the Coldcard and the BitBox, there is a Bitcoin-only model that they released, and they say that through this minimalistic software approach, they reduce the attack surface. But in the case of the Ledger, you can choose which application you want to install. So if you want to have a Bitcoin-only device, you only install the Bitcoin application.
That's pretty much the case. And the other thing is that, if you look at the source code of the Bitcoin application, you will see that to save space, you have some branches in the application that relate to other Bitcoin forks. Typically, some points that are maybe not well known, by Bitcoiners only, but you have plenty of Bitcoin forks. Even typically Zcash is initially a Bitcoin fork, so you might not be aware of it, if you never dig into the question. So if you look at the Bitcoin code, you would say that it is quote contaminated quote by some other coins. So if that's your case, you might want to think that you want even something better than that for your Bitcoin. So you might change the Bitcoin application to only contain code that's related to Bitcoin, then load it, and with better guarantees, I would say, than other manufacturers.
Right. One of the downsides that I found in the Ledger devices during my testing was that it's a lot more difficult to set up a multisig with Electrum. And are there any efforts that you are doing in this direction? And will there be a multisig option that you will be implementing in Ledger Live, which is your desktop application?
So we are definitely starting efforts to rewrite the way the Bitcoin application is working regarding multisig. So the current application, maybe for a little bit of history, it was written for first generation hardware, which had 2 kilobytes of RAM. So in 2 kilobytes of RAM, you can't do much. And the way I decided to implement multisig on that is that, I would just display the information. I will not try to be smart and understand, what the transaction is doing, and I will just sign. In the end, I thought that signing was the right thing to do for a hardware wallet. So I understand that, this is definitely not satisfactory enough if you want to build a complex multisig setup. And the vision I have for the next rewrite of the Bitcoin application that I am currently working on is that we will have more complex Bitcoin application in the future. So I think that, the multisig is one thing, then we will have taproots, then we will have mask, then we will have other features, which make me consider maybe a little bit Bitcoin, with a Unix model in mind. So if you look at the Unix model, you have a lot of small processes, that do one thing, that do it well, and that can be piped to another process. And I would like to have the same design for the next Bitcoin application. So the Bitcoin application, you will have one Bitcoin application which is responsible for just doing a Bitcoin transaction signing. You would have a sub application which is responsible for displaying the address in the multisig. You would have an application which is responsible for deciding what a multisig template is. So, for example, using miniscript or descriptors, you could say, okay, I'm going to sign using this model. Then I'm going to bind this model inside the device. So either by generating a specific application specifically for that, or by writing the profile into committing the profile to Flash, for example. And then you would say, okay, I'm going to sign using something that always looks like this. I mean, at least for this instance. And then the device can display additional information. The problem is that today it's difficult to display additional information regarding a multisig setup without assuming a lot of things. So you can assume that your keys are sorted. You can assume that your change is always going to look like, well, a given format, which happens to be followed by Electrum, but other people might not follow this format. And I think that by lacking the flexibility of exactly describing what you are going to sign, you can break some use cases. So let's say that I had the choice to make between signing and maybe displaying a little bit more information but taking assumptions. I chose not to make assumptions in the first version of the application before I had enough power, in the device and the new application model in order to describe what you're signing without making those assumptions.
Now, speaking of Electrum, because we have mentioned it, what do you think about people who buy a Ledger device and choose not to use the Ledger Live software and go for Electrum personal server or for Wasabi or for Shapeshift or other platforms that have native support for the Ledger devices? Do you have any kind of advice for them? Is it reckless to pursue this path?
Oh, it's absolutely not reckless. So the point, the way we are creating security devices, and we definitely support people using them in any possible setup. The device itself is made to be safe. So today, I would say to those people using third-party wallets to connect their Ledger device, well, please do. Ledger Live is designed to provide the most user-friendly experience, but of course we can't cater to all users. You mentioned multisig previously. The way I want to handle multisig in Ledger Live in the future will very much likely be done in an MPC kind of way. So in order to support multi-signature between different coins. So typically, if you want a multi-signature which is on-chain, Bitcoin, and so on, don't use Ledger Live because that's not something that we will plan to offer. And if you think a little bit, if you go back in history, the way we designed the hardware wallet initially, we had absolutely no support we didn't have our own wallet. So I started the integration by pushing implementations. Well, the first wallet was Green Address. I think the second one, technically the first one was CryptoKit, so it was a Chrome extension, so now it disappeared. But the second one was Green Address. The third one was Electrum. So I definitely support third-party wallets using Ledger features. I think if we want to speak about specifically some wallets, I think, Electrum will provide you more fine-grained coin control. Also multisig, as you said. Lightning, because Electrum is going to support Lightning in the next version. And today, if you want to open a Lightning channel with your hardware wallet, you can definitely do it from Electrum. So it's also a great way to use the wallet. Wasabi is going to provide more privacy. We don't support CoinJoin today, but that's something we are definitely interested to support. And as an extension to the device, as an extension to the Bitcoin application, I mentioned before that I want to consider Bitcoin as a set of processes that I connect together. CoinJoin could be one of those processes. And we are definitely quite interested to provide features. Even if those features are not supported in live, we support the software wallet ecosystem, and we definitely support the wallets connecting to us.
So let's do a short recap, because during the interview, you have mentioned lots of features that may get added to Ledger devices in the future. And I think you mentioned PSBT, you mentioned Shamir's secret backup. And
sharing backups,
yeah. And also, you just mentioned CoinJoins as something in which you're looking, and also better multisigs. What else is next for Ledger?
We have, I would say we have different ways of looking at that. So depending if you are a user or a developer, I might have different answers for that. So for users, I would say our goal is to make really using crypto easier and more widespread. So for that, we want to, the goal is to compete with the standards that we have in other industries. So we want to make crypto super easy to use. So we want to have typically paying with crypto should be as easy as doing a contactless payment, and that's the reason why we're using secure elements. So regarding Bitcoin specifically, we want to make Bitcoin more customizable. So by being more customizable, I mean the multisig profiles. We want also, well, it's not directly Bitcoin related, but slightly. We will be announcing a liquid integration as well, because liquid integration is already working. So that's a good thing for traders. We want to think about how Lightning can be protected by more hardware wallets. I mean, mostly on the server side. So if you are holding a node, I know that's a lot of features. I think that given the architecture that we have, some of those features can be developed by third-party application developers. Here I'm thinking specifically about CoinJoin. I think CoinJoin is something that can be easily done by a third party. I mean, once the Bitcoin application is rewritten. So once we have the new Bitcoin application, that's something that could be pretty easy to use for someone else. Developers, I would say we want to have a much more open platform in the future. So that's we already started doing that with the operating system and with the crypto library. We want to push that further. So we want to have most parts of the operating system open. And a hot topic for us, I mean, for developers in 2020 will be Rust as well. So we want people to be able to write Rust application into their hardware wallets, and we want to drive this ecosystem forward. Because I think that's a great way to write applications which are a little bit more, controlled. I mean, than just writing C applications. If we take a look at the future, more generally speaking, we keep iterating on different form factors. So right now we are not really decided, but we are looking at things that could be bigger. We are looking at things that could be smaller. We are also looking at things that could be more integrated. I mean, especially in my team, I'm always looking at phones and wondering how we could make phones more secure. And typically, if we manage to run our operating system into a secure element inside a phone, and an integrated secure element, so a non-physical secure element in the CPU, I would say that would be the best possible integration if we manage to have a proper, of course, I/O with that. So in order to have right display to the user. So we are really thinking. We are thinking as Ledger as a platform. So Ledger is a platform providing a secure operating system on which you can build different kind of applications. Now that, I mean, we have 3 business units for Ledger, so we are not only considering hardware wallets, we are also running the Vault, which is a solution that enables people to build their own custodianship solutions. So, which is basically bigger hardware wallets in a completely different form factor. But that's something that I have been developing a lot in the past year. And we have an IoT division on which we use the secure elements that we designed and we try to connect it to other things. So the general idea is that, for example, if you want to build a device that's collecting data from a water supply or something else, and you want to provide this data securely, you can use a secure element and you can use our operating system to do that. So you might wonder, I mean, why I'm talking about that in a Bitcoin related podcast. But the idea of looking at the company as a platform is that every time we do something that looks interesting in one of those business units, we can bring it back. And typically, we learned about how to do better backups, I mean, for users as we were designing the Vault, and that's something we can push back to the consumer devices at some point. When working on the IoT devices, we made a lot of performance improvements on the device. We need to do that because we are operating in an environment where we don't have a lot of power. So in that case, you need to run, I mean, your code much more efficiently. We are bringing that back on the consumer devices in order to sign faster. So that's really the way we are looking at the company. So even if we are not only doing hardware wallets, I mean, every part that we do contribute to the same operating system, and we push this operating system forward.
I feel like I have exhausted my questions at this point, but I will just take one from ALK2019 on Twitter, who wants to know something more specific that maybe we haven't touched very clearly, how does Ledger Manager recognize a fake ledger?
So Ledger Manager will ask, basically, so having a secure chip, Ledger Manager identifies that root of trust. I mean, Ledger Manager will ask the secure chip to sign a nonce. So we'll ask the secure chip to perform a signature given code, which is given the secret that is put by the manufacturer, and we'll verify that the secure element is answering properly. So basically, Ledger Manager is verifying that the secure element is the right secure element. That's kind of, the validation which is performed by Ledger Manager.
Okay, so Mr. BTChip on Twitter. By the way, everyone should follow you just for these insights and to better understand Bitcoin security. I feel like during the last hour, and maybe it was 70 minutes or something, but I've learned a lot, and this is definitely useful. And this series that I'm doing is meant to provide more information for users who get into this whole hardware wallet business, and they want to understand what they should buy and what is right for them. And I'm very grateful that you provided all of this information, and I'm pretty sure that at some point somebody will find it and will say, oh, this is exactly what I needed, and it offers all the explanations that I was expecting. And during this interview, I took notes regarding timestamps. So if somebody wants to just skip to that part about, I don't know, Multisig and Ledger, they can just do it and listen to the part where you talk about it, or about microcontrollers and secure elements. Yeah. So thank you very much.
Okay, so thanks. Yeah, and thanks a lot, and thanks for hosting me. And as you said, I think you are providing a very useful service to the community. So please keep doing that. Keep digging into other parts of Bitcoin. I mean, if you want to host a new podcast on, I don't know, like typically the different multi-signature solutions that can be provided, that's great. So please keep doing what you're doing.
Oh yeah. Well, actually, I was thinking that each season from now on is going to have a theme, like an album, like The Dark Side of the Moon. You listen to it, and from start to finish, it may have different songs, but they just tie together in a greater theme. And that's something that I want to pursue. And this season, I've had KeepKey, I've had BitBox, I've had Lazy Ninja, who was able to find vulnerabilities in the Coldcard and in the BitBox 02. I've had you from Ledger. And next month, I will be having Slush from Slush Pool and also Trezor. So far, it's very accomplished in this regard because I was able to get the best people to talk about the products. And possibly NVK will give in the end because he was kind of skeptical. He was like, oh, why should I join this podcast? You have already written, and he was kind of unhappy about the coverage that he got in Bitcoin Magazine, specifically when I wrote that it's easier to break the Coldcard than to break the ledger. And he was like, no, but it's made from I don't know which components he tried to describe. And I said, yeah, but the screen is easier to smash with a hammer because it's larger, it has a greater attack surface. If you want to destroy it, it's easier to destroy the Coldcard. And he was unhappy. He was like, oh, but I tested it with guns and stuff like that.
Okay, but well, I would say so. Maybe if he needs to be encouraged, I would say it's always great to have a way to push for. To give your message and to give especially more explanations to the users, because in the end, users need to understand what they are buying. So well, providing a platform where you can discuss about that, which is not doing some blind promotion of the product is great. So yeah, please come, and everybody should join.
Yeah, and also I like to think that this is like the golden age of hardware wallets, because you have all of these new products which take open source code and then they experiment with some kind of design, and you have hackers.
Oh yeah, and we didn't talk too much about that, but there are some people doing some pretty wild experiments on that. I mean, especially the Trezor code is being run on platforms that I don't think people would think running that on secure enclaves, so on TEEs. So secure enclaves are another set of security devices that we didn't talk about, but they are basically some semi-software, semi-hardware security solution that you can use on more complex CPUs. So typically SGX is a security enclave on Intel. Trezor is a security enclave on ARM. So that's a way to protect, I would say, your secrets from malware, so not from physical attacks.
Oh yeah, I agree. And all of these efforts that companies make help the end user get better security. So it might be kind of a harsh competition, especially in the marketing departments where they try to emphasize on the qualities and they possibly maximize the impact of hacks that happen. And they say, oh, that device, you shouldn't buy it because it was hacked. But at the end of the day, all of this feedback that we get helps design better products, and it's the Bitcoiners who get better security.
Oh yeah, for sure. I mean, that's the way open source is working, and as I mean, the people from Chief Crypto say, the rising tide is lifting all boats. I mean, that's definitely the case. In a new industry. I mean, we get more reviews, we get more comments. The code is reused by other people. We can comment on different stuff, and that's the way we improve as an industry.
Yeah, I very much agree with that. I'm very grateful that you gave me this time to talk. So
yeah, no problem. Pleasure is mine.
BTCchip on Twitter, follow him. I absolutely have no reason to ignore his insights. And if you want to look more of his work, you can just look up Nicolas Bacca, Bacca, on whichever search engine you prefer. It's better to not use Google anymore for reasons that might regard the establishment of the new Skynet. But yeah, thank you very much. I'm not sure if I have anything else to add.
And thanks for hosting me again. And yeah, I'm not tweeting much, so I won't spam you if you follow me. And I'm not even tweeting in French, so no problem. And again, thank you. And that's it.
Let's hear a few words from the show's sponsors. LXMI is a European cryptocurrency exchange whose name is inspired by Lakshmi, the Hindu goddess of wealth, good fortune, and prosperity. It's one of the regulated and legal cryptocurrency exchanges. On LXMI, you can buy bitcoins with most fiat currencies, and you can also do trading with top altcoins. They follow the not your keys, not your bitcoins philosophy with their integrated non-custodial wallet, which helps you manage your own private keys. So if you're into trading, then you don't have to worry about having your crypto frozen by whatever political decisions, since you're empowered to hold and move your coins whenever you wish. It's great to have new players like LXMI that respect your financial sovereignty. LXMI is launching in 2020, and for more information, please check out LXMI.io. If you're not into trading, it's recommended to move your coins to a hardware wallet or some other form of cold storage, and in this episode, you're about to find out why. Please keep in mind that this is just an ad for a sponsor of this show. It's not meant to serve as financial advice, and you're responsible to do your own research before buying anything and act according to your own decisions. Embrace your financial sovereignty with agency and precaution.
Phemex, 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 Phemex. P-H-E-M-E-X, Phemex, P-H-E-M-E-X, Phemex.
Phemex is a Bitcoin exchange with derivative trading options, which focuses on speed, robustness, and maximum uptime. Built by former Morgan Stanley executives, it manages to bring simple and accessible Bitcoin trading. In 2020, Phemex will also add S&P 500 stocks, stock indexes, forex, commodities, and more. Sign up today at phemex.com/bonus and receive a bonus of up to $72. Please keep in mind that this is just an ad for a sponsor of the show. It's not meant to serve as financial advice, and you're responsible to do your own research before buying anything and act according to your own decisions. Embrace your financial sovereignty with agency and precaution.